This is section 17, definite integrals graphically, example 4. So this kind of takes what we just did and does it again, right, essentially. And it's important that you know how to do these things, because later on you're going to have to manipulate it and find the average rate of change and all that other good stuff. And there are lots of problems like this on your AP test. Typically there's at least one in the free response section, where they give you a function and they say capital G of x is equal to the integral from 0 to x of lowercase g of t dt, or that plus something, or that minus something, or that times something, or another function. You're going to have to manipulate these functions eventually, and so we might as well do it right now. So remember, this is a massive typo. All of these f's should be capital G. So instead of that, I'm just going to change this to capital F. All right. So we have g of t to the right. So when we find f of 0, we're just finding the area from 0 to 0, right? The integral from 0 to 0, which is 0. Now we're going to find the area from 0 to 2. So if this is a semicircle and the area of a semicircle is pi r squared, and our r is 2 because that's this distance, and it's actually a quarter of it. So it's pi r squared over 4. Well, r is 2, 2 squared is 4, over 4 is just pi. So that means that area is pi. Hey, look, that area ends up being pi also. So f of 2 is the area from 0 to 2, which is pi. F of 4 is the area from 0 to 4, which is 2 pi. And f of 6 is the area from 0 to 6, so we need to find the area from 4 to 6. The area from 4 to 6 is 2 times 2, which is 4, divided by 2, which is negative 2 because it's under the x-axis. So then it will be 2 pi minus 2. All right, now we're starting to go to the left. Now remember, when you go in the wrong direction, that area is going to be negated if it's on top, and positive if it's on the bottom. Because this formula is always from 0 to x, no matter what happens, when we find that area under the curve, we're going to be going the wrong way if it's negative. All right, so we are going from 0 to negative 1. So we need to find this area from 0 to negative 1, which is 1 times 2 divided by 2, which is 1. Okay, and I'm going to put positive 1. We're just going to know that because we're going the wrong way, it's negative 1. Then we have f of negative 2, so we need to add this area, which is 2. So 1 plus 2 is 3, but it's going the wrong way, so it's negative 3. For f of negative 3, we have this total area here. Now that's 1/2 times 2, which is 1, divided by 2, which is 1/2, but it's positive and negative 1/2 also, so that actually cancels out to 0. So the area from 0 to negative 3 is still negative 3. For h, we're going all the way to negative 4, so we do have to include this area here, which is 1 times 2, which is 2 divided by 2, which is 1. All right, and that's negative 1, but we're going the wrong way, so we're actually adding 1. So it ends up being negative 2 when we have negative 3 plus 1. Now, last time, for example 3, we determined that if I have f prime of x, then I have d dx of the integral which we said was just f of x. Oops, sorry, that wasn't supposed to turn the page. Okay, so that means that we're just looking at g of x, or g of t, right? So the height, or the y value at that particular number, which is so much easier than what we just did, right? We don't even have to think about it. F prime of 4, well, that's this point right here, which is 0. F prime of 2 is up here, that's 2. F prime of 6 is down here, that's negative 2. F prime of 5, that's negative 1. Now we have f double prime. Okay, so let's take the derivative again. So if I know that f prime of x is f of x, then f double prime of x is f prime of little x. So, if that's what I get, then I'm just looking at the derivative of this graph. Well, the derivative of the graph is the slope of the tangent line. So what I'm really doing for f double prime is finding the slope of the tangent line of the graph at that particular point, which will be possible because they only ask specific ones where we can find the slope of the tangent line. So let's look at f double prime of 2. Well, the slope of that tangent line looks like this, so it's just 0. F double prime of 5. Well, that's on the line because it's linear, so we're looking at the slope, which is rise over run, so -1 over 1, which is -1. The slope at -0.5, which is right here, right? Well, that's rise over run, so -2 over 1, which is -2, and f double prime of 0. Now remember, the tangent line has to come together, and it doesn't here because we have a linear function meeting up with a curve, which means that this does not exist.